All right, welcome to lesson 11 of module 2. Let's go ahead and go over our objective and success criteria. All right, today is lesson 11. Our objective is that by the end of this lesson, you'll know the definition of congruence. We kind of talked about this yesterday, and related notation. So you'll know how to write the sign for congruence, which is this right here. You can kind of see it. It's kind of tiny, but it looks like a little squiggle with two equal signs, or with an equal sign beneath it, as well as how to prove congruence. So you know you're successful when you can prove that two figures are congruent through a sequence of rigid motions that maps one figure onto the next. Okay, let's go ahead and get started on our next slide. All right, so just to give you an overview of what this lesson looks like and what you're going to be doing, you're going to be given two shapes today. Okay, just like I have here. I have ABC and A prime, B prime, C prime. And we want to know, are they congruent? So, are they congruent? Remember, that is the symbol for congruence right here. And to do that, we're going to use what we've been learning about this last, 3 weeks or so. We're going to use our transformation sequences, or our movements. So remember, we can slide, and that's called a translation. We can rotate or turn, and we can reflect or mirror. Again, this one is called translate. All right, so if we can move these two figures and they map exactly right on top of one another, okay, they're completely overlapping, then we know they're congruent, because congruent means same size and same shape. Okay, so if we put them overlapping, then we know that they're congruent because they would be the exact same size. All right, so I'm going to show you right now how we would do that with these two figures. So we could prove A prime, B prime, C prime is congruent to ABC by first, we're going to translate along vector A prime. So it's saying go from A prime to A. So slide that down. All right. And when you slide that down and those points match onto one another, it's going to look something like this. I'll draw it real quick. Actually, yep. Okay, so this shape is going to be right here now. We slid it down. All the angles are still the same. This is my C prime. This is my A prime. My A prime is now right on top of my A, but I got to get my other sides on top as well. Okay. So from there, all I'm going to do is I'm going to rotate it up. Okay. So I'm going to rotate this around center A. So this is my center. So this is staying. Everything else is going to shift up. Okay, and when I shift it up, it's going to map up exactly on top. And once it's exactly on top, I know that I've just proved that these shapes are congruent because they line up exactly. All right, so that's what we're going to be doing today, proving figures are congruent just by moving them around and mapping them onto one another. Okay, let's go ahead and continue on to the next slide. All right, here we have another example. Okay, we are going to be starting with this figure called S, and we want to see, is it congruent to S prime? All right, so we want to do that by mapping it onto one another. So we're beginning with S over here, and you'll see that it kind of explains how you can do this. So we want to get this shape on top of this shape over here. So the first thing we're going to do is it gives us a vector. We're going to slide it along this vector MN. So we slide it along this vector MN, and it now maps to right here. And we did that so that it would line up exactly across from the place we're supposed to get it. Okay, so now we have this line L. So to go from this shape to this shape, all we would have to do is reflect it over this line. Okay, once we reflect it over to this line, it's going to map up right on top, and it's going to prove that these are congruent. Okay, so I'm going to go ahead and write out exactly what we did. So to map S to S prime, and prove congruence, first we translate S, figure S, along vector MN. Okay? Then we reflect across line L, and then it maps and it proves our congruence. All right? So this is like our little instructions that we write out when we actually are doing this. But yeah, let's go ahead and continue on to the next slide. All right, for exercise 1, we're going to be doing the exact same thing I just showed you. We're going to describe the sequence of basic rigid motions. Remember, those are translations, rotations, or reflections that would map S prime to S, or S1 to S2. So we're starting with this figure right here, and we're trying to get it here. So what's the first thing we're going to do? Well, we always want to match up at least one point. We can always just slide it. So the first thing I think we should do is we're just going to slide this point to right here. Okay, we're just going to create a vector for ourselves. And we're going to slide it up. Okay, so this new figure, after we did that translation, it's going to be like right here. Okay, and the corners match up and they're on top of each other. All right. From there, what we're going to do is we're going to be rotating this. So we want it to rotate it back until its back matches right along this line, so that they're like back to back. So then we're just going to rotate this, and now it's going to be like right here. It's going to be back to back. Okay? And now that it's back to back, all we have to do is reflect it. We're going to reflect it across this line, basically just flip it over, right? Mirror it, and then it'll map exactly onto S prime. So I just showed you this, but also that whole sequence is right over here to the right. Again, we slid it up, mapped it right here, slid it to right here, and then we reflected it across. So I'm going to write out those steps. So first step, we translate, which is our slide. The second thing we did, I don't have points here or anything, so that's why I can't really name the vector or anything like that. Then we would rotate until it matches up, and then we would reflect. So that's the order that we did these movements here. Okay? Make sure you have some sort of drawing here, right, showing that we did this right here, and also you write down those steps. Okay? Moving on. All right, this is the same kind of image, but we are now showing that S2 is congruent to S3. So we're starting here and moving down here. Okay? So the first thing I want to do is slide, right? We always want to map one corner to the next corner. So that's what I'm going to do here. I'm going to slide this figure down until the corners touch. And this new figure is going to be like right here. Okay, so step 1, translate or slide. Okay. From there, there's only one other thing we need to do, which is just rotate it, right? We will rotate this all the way around until it maps up exactly on top. and it proves that they're congruent. All right. Let's go ahead and move on to exercise 1C on the next page. Make sure you have all this down. All right, exercise 1C, I want you to attempt this on your own before you watch me do it. So I want you to describe basic rigid motions that maps S1 to S3. Okay, so from this one to this one, how would you get it there? What would you do? Go ahead and pause this video and then write down exactly what you would do, and then come press play once you have your answer down and check your work. All right, the first thing I would do is I would map my corners to one another through a translation. Okay? And once this is translated, this is going to look something like this. Okay? So first, translate corners to match up. From there, there's a few different things you could do. So you could just do a reflection over this blue line I just made and just flip it over, okay? Or you could rotate it around, match up back to back, and then flip it over. It's completely up to you. I'm going to do the least number of movements. So I'm just going to reflect, which is just mirroring, right? We just mirror it over this line. I'm just describing this as I draw it, so then I just put just reflect across that blue line because I drew a blue line for it to reflect across. Okay, and then it would end up right on top, showing that it's congruent. All right, make sure you have this down before we move on to the next one. All right, exercise 2. This is kind of having us work backwards. It says perform the sequence of a translation followed by a rotation of figure XYZ. So we're going to take this figure right here, we're going to slide it, and then we're going to rotate it. The translation is along vector AB, so translating it like that, okay? And then the rotation, it doesn't tell us how many degrees, it says D degrees, so we can rotate it as much as we want. We choose D around center O, so we're going to rotate it around here. And then we're going to label our new figure, and then we're going to answer the question, are they congruent? Okay, so the first thing we're going to do is slide it up. So I'm sliding this figure up along vector AB. So I'm starting with my Z, so this would be my Z prime. Doing my Y, be my Y prime. Doing my X, be my X prime. Not perfect, but not too bad. So I have my first movement done. I did my translation along vector AB, and then it wants us to rotate around center O. It doesn't tell us how far or how much, so it's really up to you how much you want to rotate it. New figure is going to end up maybe somewhere around right here for me. You can rotate it wherever you want, and I just want to make sure that I label it because this is my final image. Okay, and then it asks us, are these two figures congruent? Is this figure congruent to this figure? And explain how you know. Well, based on our lesson today, you should say yes. They are congruent. You should know because they map onto each other. Through a sequence of rigid motions. And that's pretty much the big idea of our lesson today, is that you can prove two shapes are the same size and shape, that they're congruent, by mapping them onto each other, by moving them, sliding them, rotating them, reflecting them so that they lay right on top of each other. And if they do, they're congruent. All right? Make sure you have this down before we go over our lesson summary. All right, your lesson summary for today. It says, given that sequences enjoy the same basic properties of basic rigid motions, we can state 3 properties of congruences. First property, they map lines to lines, rays to rays, segments to segments, angles to angles. Okay? If figures are congruent, they have the same lengths, they have the same angle measurements, all of that stuff. Okay? Number 2, it preserves the lengths of segments. So this, if you are, saying 2 shapes are congruent, they have the same lengths of every line segment that matches up. And the same with their angle measurements. Okay? So if a figure is congruent to another figure, they have the same measurements for their angles. And then the last thing you learned today is that the notation, or the sign, we use for congruence is this little squiggle with an equal sign beneath it. Okay? Make sure you understand these things before you move on to the exit ticket and reflection for today, okay? All right, today's exit ticket is posted in Galileo for you to complete. It does talk a bit about congruence, and then has you mapping some figures onto other figures. Once you have that reflection or that exit ticket done, then please go do your reflection in Google Classroom. Look out for any missing work you might have. Make sure you're up to date on your MobyMax, and make sure you've attempted the projects or credit if your grades kind of slack in a little bit.